All right, here we go. All right, solving proportions. A couple things we need to take care of here real quick. First question, I would jot this down. What is a ratio? What is a ratio? A ratio is basically a fraction. A ratio is basically a fraction. It is one number compared to another, okay? One number compared to another. So a ratio could be, bless you, 3/4, okay? 3 things compared to 4 things, okay? But a ratio is basically another word that says fraction, okay? Now, why is that important? Okay, because of the next question. What is a proportion? What is a proportion? A proportion is going to be where we take two ratios, and we set them equal to each other. What is a proportion? A proportion is basically where we take two ratios, two fractions, if you will, and we set them equal to each other. Now, I didn't put any numbers in this. I just used variables. A over B equals C over D, okay? What is a proportion? Basically, when we take two ratios and we set them equal to each other. Okay? Third question, and I think this question was on your warm-up today. How do I know if ratios are proportional? How do I know if ratios are proportional? It's going to be about cross products, okay? Cross products are equal. Their cross products are equal. What does product mean? Multiply, okay? So when we talk about cross products, we are talking about cross multiplying. And I hear some of you guys, it depends on how you were taught, some of you guys were taught the butterfly method, okay? All right? So how do I know if ratios are proportional? Their cross products are going to be equal. Okay, and if we go on the proportion that I've got up here, that would mean that the product of AD would be equal to the product of BC. How do I know if ratios are proportional? Their cross products are going to be equal. Okay? And I think it's proportion stuff that tends to leak back into that multiplication of fraction stuff, because it always seems like when we multiply with fractions, everybody wants to do the butterfly method. They want to cross multiply. And I think it's the work with proportions that kind of leaks back into that, okay? And guys, those are just things that hopefully if we see them enough times, hence the warm-ups, okay, we can kind of keep those things straight. But remember, multiplication of fractions across the top, across the bottom. But with proportions, we will be cross-multiplying. This is your butterfly method, okay? Any questions here? Everybody okay so far? All right, can I go to the next slide? Okay. All right, so what if they give us some proportions, okay, and they want us to know, are these ratios proportional? All right, are these ratios proportional? Now, notice what we've got here. We've got a couple of fractions that are equal to each other, a couple of ratios that are equal to each other. All the numbers are there. And guys, all you're going to do, if you just want to test to see if a couple of ratios are proportional, we're going to cross-multiply them and see if their products are equal. And guys, it doesn't matter which cross product you do first, okay? So for instance, I'm going to do 2 times 12 first. So I'm going to go 2 times 12. And we're going to see if that's going to be equal to 3 times 8. Okay, so here's our cross products. What is 2 times 12? 24. And what's 3 times 8? 24. Is 24 equal to 24? Yes. Of course it is. Okay? All right? So we would say these ratios are proportional. Okay? These ratios would be considered proportional because their cross products are indeed equal. Okay? But this is how we can test. We can test to see if a couple of ratios are proportional. Everybody good with that first one? Okay? All right, so let's go to the second one. We've got 4 over 5. 4 over 5 is equal to 3 over 7. Okay? This time, I'm just going to go, just for whatever reason, I'm going to go 5 times 3 first. So we're going to go, is 5 times 3 equal to 4 times 7? Is 5 times 3 equal to 4 times 7? 5 times 3? 15. 4 times 7? 28. Is 15 equal to 28? Okay, obviously it is not. Okay? Those are not equal, therefore, those ratios are not proportional. Okay? But if they ever start asking you to compare ratios as far as, are these ratios proportional? Are these fractions proportional? Guys, that's all you got to do. Okay? Look at the cross products. If they're equal, they're proportional. If they're not, forget it. Okay? So far, so good? Okay, next slide. Everybody good? Okay. All right. Okay, so let's start solving some proportions, okay? Obviously, they're not always going to give you all the numbers, okay? You're going to have to go find the numbers for a lot of these to find out what is going to make the ratios proportional, okay? So here we go. We've got a proportion here. 3/8 is equal to x over 16, all right? Solve the proportion by creating a small equation. And that's something I want to emphasize here, okay? When you solve a proportion, you are really creating a very small equation, all right? And in a couple of examples here in a minute, I'll kind of show you why that's important, all right? So right here, and again, it doesn't matter which one you do first. I'm going to go 8 times x first. I'm going to go 8 times x. 8 times x is 8x. That is going to be equal to the other cross product of 3 times 16. Okay? So again, remember, we are creating a very small equation here. Okay? 8 times x is 8x. That's going to be equal to 3 times 16. What is 3 times 16? Thank you. 48. So we generate a very basic one-step equation here. What's the one-step solve here?
Divide by 8.
Divide by 8 because that's 8 times x, right? Let's divide both sides by 8. 48 divided by 8. 6. Okay, 6. 6 is that missing number that is going to make both of these ratios proportional. Okay? But again, this is, basic equations. Again, we've really emphasized equation solving. These basic equations are going to continue to show up in these different areas of concepts, okay? So again, when we see these equations, we need to be efficient and very accurate in solving them. All right, any questions here? Pretty basic. Okay? Let's do another one. All right? Sometimes they're going to move that variable around a little bit. Okay? That variable is not always going to be in the same spot. This time we've got 6 over 5 is equal to 8 over x. And again, this time, I'm going to multiply 5 times 8 first. And again, guys, it does not matter. It is completely your preference. So just for kicks this time, I'm going to go 5 times 8. That product is going to be equal to 6 times x. And if you always want the variable on the left, do the cross product that involves the variable first. Okay? I mean, it's completely your preference. Okay? 5 times 8? 40. Divide by 6. Okay? And remember, we've talked about this. Okay? We go to that division step. We know that it's not going to work out evenly, so to speak. Guys, create the fraction. 40 over 6. Can I reduce 40 over 6? Is there a number we can divide both 40 and 6 by? 2. Let's divide both of them by 2. 40 divided by 2 is what, 20? And 6 divided by 2 is 3. Okay? Guys, it's okay. Create the fraction. It's not the most ideal situation because it is creating a fraction. But create the fraction, reduce the fraction. Reduce it to lowest terms. Improper is okay. 20 over 3. Call it good. Okay? Yes, sir.
So we divided by what number?
We divided both the 40 and the 6 by 2. Was that your question?
Yeah.
Okay.
I thought you only divided 40 by 6.
Well, it's 40 divided by 6, which isn't going to work. 40 divided by 6 is not going to work evenly. 6 will not go into 40 evenly. So we're going to look at that fraction and say, okay, can I reduce that fraction? Can I reduce both of those numbers? Can I divide both of those numbers by a common number? And we could. We divided them both by 2. 40 divided by 2 is 20. 6 divided by 2 was 3. 20 over 3 makes these two ratios proportional. When 20 over 3 goes in here for x now, these two ratios are now considered proportional. That's what we're trying to find. What is the missing value that makes this, which makes these ratios proportional? I'll say it that way. Okay? Other questions? Good. Guys, ask your questions. All right. Okay. All right, let's take a look at this. Okay? This next couple of examples, this is why creating that equation is going to be important, okay? If you take a look at the denominator of that first ratio, you've got an x plus 3. It's not just an x. It's whatever x is, added 3 to it, okay? So there's a little bit more to this, all right? We are still going to cross multiply. Now, I'm going to do this first, okay? That is going to be 2 times x plus 3. It's not just 2 times x, it's 2 times x plus 3. I would strongly encourage this step right here. I would strongly encourage you to put the 2 there, open a set of parentheses, put x plus 3 in the parentheses. Because 2 has to be multiplied to not only the x, but the 3 as well, which is distribution. Okay? So I would highly encourage that step there because I think you guys will visually recognize that as, hey, I need to distribute this too. Equals my other cross product, which is going to be 8 times 5. Michael, question.
So you like, what, 6x?
Well, we're getting there. Okay? We've got to multiply 2 times x and then 2 times 3. Okay? So right here now, we've got to distribute the 2. 2 times x is 2x. 2 times 3 is 6. And 8 times 5 is 40. One of the common mistakes that I've seen for a lot of years in a situation like this is the student will multiply 2 times x and get the 2x, but a lot of times they don't get the 2 to the 3 because it's not a typical looking distribution, okay? So we need to be aware and recognize when we see this look, we've got to go, okay, this is distribution. And again, that's why I think writing it like that right there in yellow, I think that helps. It's kind of a visual trigger, if you will. You guys are pretty accustomed to seeing parentheses and thinking, okay, multiplication. Is everybody okay with where all that came from? Okay, what would be next? This is a pretty typical two-step equation. What do we got next? Subtract 6. Divide by 2. Works out nice and neat, nice and tidy. Okay? But again, here's that equation solving coming back into play with these proportions. Okay? We've got to know what to do with the proportion, how to generate the equation. But once we generate the equation, now you've got to be able to solve it efficiently and accurately. Okay? Very basic two-step equation, and that needs to happen pretty quick. Subtract 6, divide by 2, bang, done, 17. Okay? Any other questions here with this one? A little bit more involved. Okie dokie. All right, let's go to this one. Six over x minus 8 equals 3 over x plus 6. Jot it down. How many distributions do we have here? 2. We have 2 distributions here, okay? And again, guys, it doesn't matter which one you do first. This time I'm going to go here first. I'm going to go 6 times x plus 6 equals, and then I'm going to go back the other way, 3 times x minus 8. Doesn't matter which one you do first. The initial equation is basically going to be the same. 6 times x plus 6 equals 3 times x minus 8. And you might be somebody that gets good at recognizing what's going on, and you might be able to distribute without that step right there. And if you are, awesome, do it. But guys, if that distribution's getting you, I would highly encourage that step right there. Show the parentheses, because I think the parentheses are a good visual trigger for you to go, I need to distribute here. Here we go. Let's distribute. 6 times x.
6x.
Boom. 6 times 6.
36.
Equals. 3 times x.
3x.
3x.
24.
3 times negative 8.
Oh, wait, my bad. Negative 24.
Negative 24. Okay? Is everybody good where all that came from? Can you wait just a couple minutes? I don't want you to miss this. Guys, we got variables on both sides of the equation, okay? 6x plus 36 equals 3x minus 24. Again, remember, it doesn't matter which side of the equation the variables go on. Where do you want to put the x's, left or right? You'll put them on the left? If we're going to go left, which one's moving?
3x.
And how's it going to move?
You're going to subtract 3x.
Beautiful. I agree. Let's subtract 3x from both sides. 3x minus 3x, gone from the right side. All you have left is negative 24. On the left side, 6x minus 3x, 3x, plus 36. Get those variables to one side or the other, okay? What's next? Subtract 36, I agree. Let's see, negative 24 and negative 36 are negative 60, I believe.
Yep.
If you add two negatives, you're going to get a negative. Those dang integer rules never go away. And then how do we solve? Divide by 3. Negative 60 divided by positive 3. Negative 20. I got it. Negative 20. Good job. Thanks. Again, a little more involvement here. A little bit more going on. Okay? Guys, it's going to be hard to just sit and look at these and try to figure it out. Okay? Sometimes with basic ratios, proportions, you can kind of do that. With these, it's a whole lot tougher, okay? So again, I would encourage some kind of steps on the side someplace, but we're after negative 20 in the end. Any questions with that process there? I got one more example. All good? Fantastic. Okay. All right. A lot of times on these tests you guys take, they always run some ratio proportion problems at you, okay? And a lot of them read a lot of the same way, all right? So I'm going to do an example of one. On the assignment today, I think I've got 3 little problems like this, okay? But a lot of times they're comparing an item to a price. They're talking about maps and converting like inches to miles and stuff like that. But, once you read enough of these, you kind of catch on to a ratio proportion problem. It's kind of like, oh, okay, I need a ratio proportion here. Right here, a bakery sells 14 donuts for $9. How much will it cost for 22 donuts? Okay, so ratio proportion problem. I gave you a couple of reminders here, okay? Set up your ratio. Guys, what are the two things being compared here? What do the two numbers represent? 14 and 9. What does 14 represent? 14 donuts. And the 9 is talking about price, dollars, right? Guys, the two things being compared here are donuts and dollars, okay? So when I say set up your ratio, we're going to set up a ratio, and listen here, guys, it doesn't matter, okay? You can either go donuts over money or money over donuts. It doesn't matter. You just have to be the same on both sides of the proportion, okay? So what I'm going to do is I'm going to go donuts over money. That's how I'm going to set up my ratios. Every ratio that I write in this problem is going to be a donut number over a money or a dollar number. Set up your ratio. Make sure both ratios are consistent in their comparisons, okay? So here's what we're going to do. We're going to go 14 donuts over $9. 14 donuts over $9 equals, what does the 22 represent, donuts or dollars? Donuts. So is the 22 going to go on top of the ratio or the bottom? It's going to go on the top. 22 donuts. Do I know how much money 22 donuts is? So what do you think I'm going to put down there?
Mr. King,
Absolutely.
what's on top of your dollar?
D for donuts. Okay? You must be consistent. When you set up a proportion, if we're going to go donuts over dollars, then the numbers on top have to be donut numbers. The bottom numbers have to be dollar numbers. Okay? If you wanted to flip it over, you could have done it this way. It doesn't matter as long as you're consistent with both. Okay? Guys, the most difficult part of this is going to be the setup. Okay? If we can get the proportions set up, the rest of this should be pretty easy. We're going to cross multiply. We're going to go 14x equals 9 times 22. Right? Cross products. Cross products. 14 times x, 14x. 9 times 22. And if you look down here, guys, notice the cross products would have been the same. If I would have flipped those ratios over, we're still getting 9 times 22. We're still getting 14 times x. Be consistent in your ratios, and you shouldn't have a problem. Okay? Let's see here. 9 times 22, that's 18. Carry 1, 18, and 1 is 19. 198. Somebody want to check my math on that? Is that right? Okay, thank you. It is a Tuesday off a 3-day weekend. How do we solve? Solving step? Divide by 14. Will somebody do that for me, please? What we got?
It's 14.14.
14.14? Thank you. Okay. So, how much money is that? Because that's what we were trying to find. How much will it cost for 22 donuts? So what is 14.14? How do we say that in dollars then? $14.14. Okay? So again, pay attention to the question. Okay? They're asking us about money. A decimal is going to be okay. 14.14 would be $14.14. That makes sense, right? It's like, okay, all right. Now, if they were asking us for donuts, could you say, hey, give me 14.14 donuts? Okay, let me tear you off 0.14 of a donut here with, see what I'm saying? So make sure that we're answering the question and the answer is appropriate for the question. They're talking about money. We want to know about money. 14.14. Money, there's decimals involved with money. $14.14 makes sense. Okay? So that would be our answer for that problem. Okay? But you're going to have, I think there's 3 of those. And I think one of the problems is a bakery problem. I tried to give you one that's very similar, okay, to what you're going to see on the assignment to kind of be able to kickstart you there. But a lot of these types of problems kind of read the same. Guys, it's comparing 2 things. Here it's comparing donuts and money. Might be a map where they're comparing inches to miles. Okay? Dollars to gallons of gas. I mean, it just, if I can go 400 miles on 10 gallons of gas, how many gallons will it take me to go 875 miles? All those types of problems kind of read the same. Okay? Questions here with the proportion problem? Okay?